Math with Mr. Williams, example 1. Which of the following statements describe the linear model shown? Select all that apply. So here, let's take a look. We have hours worked compared to earnings in dollars for a food server. And the first one says, for every 3 hours worked, earnings increased by $10. So that means if I go from 0 over to 3 and I go up, I should find that $10, but it's not. It's up around 65-ish. So we know it's not going to be this one. All right, so let's take a look at number 2. It says for each hour worked, earnings expected to increase by 20 bucks. So that means every time I go to the right, I should be able to go up to 20. The first one looks like it's directly across from 20. Let's try the next one. So I go over one more, and I'm at 40. So 20 plus 20 is 40. So I know I can see this trend. I'm looking for a stair set, and yes, there it is. So this one works. All right, on to 3. The hours worked has no correlation to how much someone earns. So the key here is the no correlation. I mean, there's not a relationship, especially a linear relationship between the two. But I can see there is a line actually drawn on the graph itself, and I can see that every time I move to the right, the earnings are increasing. So this is not true. All right, on to number 4. Someone who works 4 hours should expect to earn $80. So the key here is the 4 hours, and they're going to earn about 80 bucks. So I go across where it says 4 for hours worked, and I go up till I hit the line, and yeah, it's pretty close to the 80, so I'm going to say yes on this one. Now on to the last one. It says someone who works 4 hours should expect not to earn any money. So I know I found the last one, 4 hours was 80 bucks, but for it to say not earn any money, well, we know that's going to be false because we can see no matter how many hours we work, we're going to earn something. So this one is false. So 2 out of the 5 possible answers. Math with Mr. Williams, example 2. A lawn mowing business is analyzing the number of days worked and the number of lawns mowed. The data is shown on the graph below. Which statement is correct based on the data? So in this case, we realize that we're only looking for one statement. So let's look at the first one. If the days worked is 3, the amount of lawns mowed will definitely be 25. So we're looking for days worked 3 and mowed would be 25. So I go from 0 over to 3 and I go up to where I see the dot is, and I can see it's just above 25, and the word was definitely 25, so I know this is not going to be the correct answer. Let's go on to number 2. The days worked give no indication of lawns mowed. All right, so there is an indication here actually. You can kind of see as the days are increasing, the lawns mowed are also increasing. You can almost draw a line through the relationship. So the key here is the no indication. So this one is also false. All right, on to 3. The number of days worked is correlated, has a relationship to a higher amount of lawns mowed, but does not necessarily result in the lawns being cut. Okay, so correlated, so we're looking for that coefficient. So we see, is it on a line? Is there that linear relationship going on? And we proved in the last one there was that linear relationship. So I'm gonna see if I can draw a better line for you. And there we go. So there is a relationship here. The problem but does it not necessarily result in the lawns being cut? Well, so just because someone is working does not actually mean those lawns are being cut. It could be raining, the numbers could go down. There's a lot going on. So this part that not necessarily results in the lawn being cut, that's true. So I'm going to go with true on the third one. Going to number 4. The number of days worked is correlated, has a relationship to a higher amount of lawns mowed. We said that was true last time. And the second part says, and causes the lawns to be mowed. So do the days cause the lawns to be mowed? No, those are the workers. So we know this one is definitely false. So out of the 4, we've selected our correct one. Math of Mr. Williams, example 3. The following scatter plots show relationships between 2 variables. Draw a line between the correct correlation coefficient for each graph. So here we see the first graph. It looks like we have a downward trend. If we draw a line through most of the dots, we can see it's going to be a negative correlation. So the only one that's negative down here is this one. So if we go to number 2, I don't know if I can draw a line through that. So I can see that's probably going to be the no correlation. And then if I look at the last one, we see that it's definitely going upwards. So we know that's going to be the positive, and the only one left is positive. So that is really nice. So let's go over here and see if we can draw a line through it. Yes, we can see that that is pretty close. So I'm going to go with the positive 0.85 or 85 hundredths as my answer for number 3. Math with Mr. Williams. Example 4. Find the mean, median, and mode of the data with and without the outlier. Which measure does the outlier affect the most? Round to the nearest tenth. All right, so I have my numbers of 4, 5, 8, 4, 6, 9, 32, and an 8. I can quickly see that 32 is probably the outlier because everything else is single digits. So what I'm going to do first is I'm going to draw a quick T-chart. All right, and now let's go ahead and place our numbers in order from least to greatest. So the first number would be 4, then another 4, then a 5, then a 6, then 2 eighths, a 9, and a 32 finally. All right, I like to start with the median. So I can see there is 8 numbers here. So I need to go over 3 on both sides and see my 2 in the middle. So 6 plus 8, that'll give me 14. And so 14 divided by 2 will get me 7 for my median. All right, for the mode, I can quickly see that I have 2 4s, but I also have 2 8s. So the mode is going to be 4 and 8. All right, and now for the mean. For the mean, remember, it's an average, so what we need to do is add all those numbers up. And if I add all those numbers up, I get 76 for my total. And I need to divide that by how many numbers I had, and that was 8. So 76 divided by 8 will get me 9.5 for my mean. All right, now I need to eliminate that outlier so I can see that that 32, since he was double digits, he is off the page. So I'm going to bring all this over this way and find my mean, median, and mode without that outlier. So I'm going to write the numbers down again, this time not having the 32 involved. And let's find our mean, median, and mode. So I'm going to start with the median again. I can see this time we have 7 total numbers, so I'm going to go over 3 on both sides again. And I quickly find my median is 6. All right, now does my mode change? I don't think so. I see 2 4s still, and I see 2 8s. So the mode is still going to stay 4 and 8. All right, let's see how the median gets affected. So let's go ahead and add all those numbers up, and we arrive at 44 for our total. We divide that by 7 numbers this time, not 8 because we got rid of the 32, and we arrive at a long decimal. Let's go ahead and round it since it says round to the nearest tenth here. So I know I need to underline my 10th spot. I'm going to box number behind it. He's an 8. He's going to round that 2 up to a 6.3 for my mean. Okay, so the question asks, which measure does the outlier affect the most? Well, we can see the median only changes by about 1. And the mode, well, it doesn't change at all. But you can see the mean, he's 9.5 and 6.3. So the one that gets affected the most is going to be the mean because he has the greatest difference between our answers with the outlier and without the outlier. Math with Mr. Williams. Example 5. The table shows the distances that schools will travel to attend a field trip to the zoo. School 7 has to travel 5 miles. If this outlier is added to the data, which is a true statement about how it changes the data in the table? Round answers to the nearest tenth. Select all statements that apply. Okay, so let's go ahead and start off with just putting the numbers in order from least to greatest. So here we have 15, 20, 38, another 38, 40, and 42. All right, let's go ahead and start off with finding our median. So we see we have 6 numbers, so we draw a line 2 over on both sides, find those 2 in the middle, giving our median as 38. All right, and our mode will be also 38, due to there being 2 38s in the number set. Now for the mean. All right, mean is when we add all the numbers up and we divide by how many numbers we have. So we add all these numbers up, we arrive at 193. We divide that number by 6, giving us our rounded answer to the nearest tenth of 32.2. So our median was 38, our mode was 38, our mean was 32.2. Let's go ahead and find the range. Our range is when we subtract the greatest number from the least number. So we have 42 minus 15, and we get 27 for our range. All right, now let's go ahead and add that outlier in. So we're going to start off by putting the 5 miles in with the rest of our numbers, giving us 7 numbers total. So this time we're going to go over 3 on either side, finding our 38 for our median. And then the mode doesn't change at all, so we're going to keep it at 38. Now let's take a look at the mean. That means when we add all those up, so originally we had 193, we're just adding that 5 on, so we're now at 198 for our total. And we're going to divide, instead of by 6 this time, we are going to divide by 7, giving us 28 and 3/10 as our rounded answer. Giving us 28 and 3/10 as our rounded answer. All right, and lastly, our range. Our range is when we subtract the greatest number minus the least, so 42 minus 5, and that'll give us 37. Okay, so now we have all the numbers we're looking for our measure center and variation. And now let's go ahead and take a look and see which answers are correct. So the first one says the data is less spread. So spread refers to the range. Okay, so we're looking for, did the range decrease? So the range we start off with was at 27, and now it's at 37. So it actually increased. So this one is false. All right, the median stays the same. All right, so we can see the median in the first part was 38, and the median in the second part is also 38, so that is true. The mean changes. All right, so the mean in the first part was 32.2, and it changed down to 28.3, so that is a true statement. On to 3, both the median and the mean change. Well, we proved that the median did not change, so we know this one is false. Fourth one, there is no change in the median and the mean. Well, we know the median stayed the same, but the mean changed, so we know this one is also false. The fifth one, it says the data is more spread. So spread, remember, refers to range. Okay, so if we're looking at that, we see that originally it was 27 and now it's at 37, so it is more spread out. So this one is true. All right, so the next one, there is no change in the spread of the data. Well, we just proved in the last one, there is a change. It went from 27 to 37, so this one's false. And lastly, the median changes and the mean stays the same. Well, we just proved earlier that the mean actually stayed the same at 38, but the mean changed. The mean changed from 32.2 up to 28.3. So this one is also false. So only 2 of those items are correct. Math with Mr. Williams, example 6. A car dealership looks at 15 salesmen sold cars and organized their data in the box plot shown. What can be inferred, meaning deduced or concluded, from the data? Select all that apply. So we see a box whisker plot. We see that there are our 5 dots, or our 5 number summary. Let's go ahead and write those numbers down. So we see 4 is our least number. We see our Q1 is an 8. We see our median is sitting at 10. We see our Q3 is at 16. And we see our greatest number is at 24. All right, now that's 5 numbers. Now we have 10 other numbers we need to come up with. So let's go ahead and just add a few numbers in. So let's say we have a couple 4s down here. Let's say we have a couple 8s, and we'll throw another 10 in. And then above the 10, let's go ahead and throw another 10 in, maybe a 14, and how about a 15 here between 14 and 16. And then between 16 and 24, we see that long line out there. We know we need to at least put a few more numbers in. So let's go ahead and say, how about 18? And let's throw a 20 in there. All right, let's make sure we have the correct number of numbers because we're looking for 15 of them. Yep, it looks like we have 15 numbers. So now let's go ahead and use that information to find the mean. So if we just go ahead and add all those numbers up, we're going to arrive at 173 total. Now let's go ahead and divide by 15 for the 15 numbers, and we get 11.5 for our mean. Now our median is still the same. It's still sitting there at the 10, so our median is still 10. All right, so now I have all my information I need. I noticed there was no mode in there, so I didn't go looking for the mode. So the first question says the mean is probably more than 10 cars. Well, based on the numbers we put in there, the mean is 11.5, so that is going to be a true statement. And you kind of get the idea that it's going to be true just because the numbers are skewed right, meaning that they are spread out more on the right side of the data. All right, so the mean is equal to the median. Well, in this case, the median was 10, the mean is 11.5. It is definitely stretched more to the right side, so we know this one is going to be false. All right, third one, the mean is probably less than 10 cars. Well, we know the numbers, and we just proved it above, that the numbers are spread to the right. Therefore, this one is also false. Fourth one, if another salesman is recruited and sells 30 cars, the mean must change. Let's just go ahead and prove it. So out of that list, there was 15 numbers. Now we're going to add that 30 on at the end. Let's go ahead and get a new total. Adding 30 on to 173, giving us 203. We're going to divide that, instead of by 15, we're going to divide it by 16, giving us about 12.7 for our new mean. So does it change? Yes. Anytime you add another number on, to a number set, it's like doing well on the next test. Your score should go up. Your average overall for that class should increase. But if you get a bad grade on that test, your score should decrease. So the mean must change. All right, now for the last one. If another salesman is recruited and sells 30 cars, the median must change. Well, if we have 16 cars now, let's just count over 7 on each side. We can see we have two 10s here. So 10 plus 10 divided by 2 is still going to keep us at 10 for our median. So does it have to change? No, it doesn't have to change. That's the key word there. Now, could it change? Yes, it could change if I didn't have 3 10s sitting in the middle. I could have put a couple 11s there, and then yeah, it could have been 10.5. But must it change? No, it does not have to change. We just proved it in that number list. So out of the 5 possible answers, we selected 2 of them.